Hello and welcome to GeoProven and part 2 of our series on transformations. This is the second of 5 of a video series on mathematical transformations. We discussed translations last time after defining what a transformation is and what it does. Translation moves a figure, a pre-image, into an image. In this video we're going to discuss rotations, which obviously rotate an image. It rotates the image around an origin. The third video will be on reflections. The fourth video will be on composite transformations, doing several of them all in a row. And then the fifth series will be on matrix forms of transformations. This lecture series has a lot of application to many different fields, but in geology to crystallography, and certainly on the computer screen, computer graphics. So this series again is on the rotation transformations, and we're going to start with the rotation 90 degrees clockwise. So this is a rotation where the figure is going to move just like the hands of a clock in a clockwise direction. We would call that a 90 degrees clockwise rotation. Sometimes it's abbreviated with a CW. It's also a minus 90 degree rotation because the convention of trigonometry, a counterclockwise angle goes from the is measured from the x-axis to the position of the point or figure that's been rotated. In a counterclockwise direction, that's positive. But then in the clockwise direction, which moves the figure in the direction of the hands of the clock, that's a negative angle. Or if you'd rather, you could even think of it as a 270 degree rotation the other direction. In the counterclockwise direction, a positive 270 degrees is the same as a negative 90 degrees. So last time we had a pizza slice that we put together from 8 different lines, for about a total of 64 points defining the figure. And in computer animation, you know, we might have a figure that is made out of millions of points, and a computer will do all of the transformations. And anyway, last time we moved this pizza from its original location, we put the corner over at the origin. So there's a translation of the figure with now the corner up into the origin of the middle of the graph. We've been talking about a random point that I'm running through, an arbitrary point that is, that I'm running through each and every one of these transformations, the 0.74. That's just any point that I wanted, but I wanted the x to be different than the y. And I chose to use positive values because they're easier to work with and explain. So the first one is going to be the clockwise rotation. Now when you do a rotation, it's around the origin, so you can sort of think of the rotation as being a sweep from a radial arm that extends from the origin to the point in question. The vector notation for a clockwise rotation is given as a capital R with a subscript 90 clockwise, or possibly minus 90. 270 are the same thing. So there's a sweep of a 90 degree clockwise rotation. So this is the minus 90 angle, minus 90 direction from the random point plotting in the middle of the sausage to the point down in quadrant 4 there. Coordinate rule for the notation is as follows. The xy goes to y minus x. So there's a change of sign on the coordinate, as well as the coordinates being swapped. So the coordinates are swapped and the y value is made minus. So the example 0.74 then goes to the 0.4 minus 7. And here's what that looks like. Here's the random or the arbitrary 0.74 being swept, and here goes the entire pizza slice. And it's got a ghost image sweeping to the final position. When you look at that, it looks like it may have been distorted, like it went into the graph a little bit or into the third dimension. But that's only because you have a perspective change. This is a thick crust Chicago pan style pizza, and so the The perspective drawing of the thickness of the crust is maybe making the figure look a little bit distorted. We can take that out. Let's get rid of the sweeping arm. And there's getting rid of the thicknesses. So there you can maybe see that each one of the figures is only rotated 90 degrees. And we get rid of the ghost, and that's what's left. So now we're going to rotate in the other direction, the 90 degrees counterclockwise rotation. And that's a positive 90 degree rotation because, again, the trigonometric convention is that a positive angle in rotation is measured from the x-axis positively in the counterclockwise direction. Here is the figure that's been translated to the corner on the origin. The random point is again in the middle of the sausage on the edge there. We're going to look at the vector notation is the capital R. It can be 90 degrees counterclockwise with CCW for the abbreviation, or because it's positive, just 90 degrees in the subscript. We again think of a rotation as a radial sweep from the origin. The random point then moves from its current position, swept by the radial arm, to that new position. The coordinate rule for that rotation, the coordinate rule notation is a 90 degree counterclockwise rotation. The point xy goes to minus yx, so the x and y are swapped and the minus becomes negative, or the x coordinate becomes negative. The example point 7, 4 is translated to a minus 4, 7 coordinate. So there's the original piece. Let's move every point in the figure. And this is what you get with the ghost left over. Getting rid of the ghost and the sweeping arm, that's the final figure from the 90 degree counterclockwise rotation. So the third and final rotation that we'll look at is one that goes 180 degrees, basically halfway around the circle. Again, here's the original figure with the corner at the origin. You got the random point 7,4, the arbitrary point 7,4. It's plotting in the middle of the pizza sausage. The vector notation for the 180 degree rotation is an R with a 180 in the subscript. There's a radial arm that it's going to sweep 180 degrees around from the random point about the origin to a new point. Therein lies the new point. The coordinate rule for that 180 degree rotation is that the point xy goes to minus x minus y. So taking the arbitrary point 7,4, the 7,4 point goes to minus 7 minus 4. So if we do that for every point in the figure, it goes like that, where the ghost is left there. Getting rid of the ghost and the sweeping arm, that's the final position of the figure after 180 degree rotation transformation. So that concludes the three rotations that we're going to look at: the 90 degree clockwise rotation, 90 degree counterclockwise rotation, and the 180 degree rotation. This is a summary of all of the transformations in the 5-part video series. The first subject was translation, the coordinate rule above, and here are the coordinate rules for the rotations. And the subject of video 3 is going to be the reflections. I hope you enjoyed that video. Please join us for the third part.